Alright, on to the general problems. Problem 73. We have an helium gas cylinder which is set to a pressure of 32 atm. And then we blow up a couple balloons and the pressure decreases to 5 atm. So we can write down P1 for the initial pressure and P2 for the final pressure. The question is, what fraction of the original gas remains? So to do this, we will need to find the number of particles before and the number of particles after and compare those two numbers. From the ideal gas law, we have N equals PV over RT. And so we can rewrite this actually as N over P. Not right. Blue. You know what? Let's just write blue. N over P equals V over RT. Okay, so this is true. I'm going to write N1 and P1 here. This is true for the original scenario where the pressure is 32 atm, so P1 in blue here. And then for the final scenario, same equation holds but with different variables. And the reason we can write this like that is because the volume doesn't change. We have the same gas cylinder, and the temperature, well, we assume doesn't change either. So that leaves us with N1 over P1 equals N2 over P2. So let's rewrite this the way we want it. We want to know the fraction of original gas that remains. So that would be N2 divided by N1, right? Because N2 is the quantity of helium that remains in the cylinder, and N1 is the quantity that was originally there. So N2 over N1 will be the fraction of gas that remains. Right, so from this equation, if I want N2 over N1, this means I'm going to have P2 over P1 on the other side. And we know P2 over P1 is 5 over 32. And 5 over 32 for me is actually 16%, which is slightly different from the 18% of the solution book. So maybe there is something wrong in our approach here. But the 16% was close enough from the 18% that I'm thinking there must be some rounding off error somewhere in the manual, or not here because we haven't rounded up anything until the end. Anyway, I am not sure why the 16% doesn't correspond to the 18% from the manual. And so that's something you might want to check out. So sorry that I can't reproduce exactly the answer from the manual. I'm going to flag the answer as incorrect because I believe the correct answer is actually closer to 16%.